Hello. Doing chapter 1-8 today, graphs and functions. So we'll be covering how to interpret, which means how to read, decipher, and understand what the graphs are talking about, as well as basic drawing of graphs of functions. So in the first graph here, we're looking at days, which represent our x value. As the number of days increase, so as x increases, what happens to y? So, as the days increase, the value of y also increases. So, x increases, y increases. That's basically the understanding that we're looking for right off as 8th graders, that you can figure out. As the number of days increase, the amount of percent of blood flow actually increases to the brain. Alright, on page 2 here, we're looking at a bunch of definitions for graphing. We should know the basics of graphing here. Okay, we have a function. Now you remember these from younger ages. You have the old function box. You have a rule. As you plug in x into the box, you do some operation to it, and out comes y. So, looking at that, we have the vertical line, the vertical axis, and we know this as y. Above the 0, it's positive y. Below the 0, it's negative y. So, that's the y-axis. The x-axis is the horizontal axis, the one that goes this direction. To the right of the 0 is positive x. To the left of the 0 is negative x. Alright, now, this is all called the coordinate system. Basically, what it means is you have a bunch of coordinates which are x, y, and you graph it. So in this situation right here, we have the coordinate 4, 3. The first value is an x, the second value is your y. You remember from younger ages that you would count over 1, 2, 3, 4, and then go up 3. 1, 2, 3, and that's how you would graph it. But you just plot the coordinate. You don't leave the little scribbly lines, so you want to erase those. Okay. The origin is an important piece to think of. It has the value of 0, 0. When x is 0, when y is 0, it is located right here. That's where you start counting from everything. Alright, every coordinate is also called an ordered pair. Basically, it's your x, y value. Now, later on, your x's and y's can change to other letters like L and M and P, whatever else you want it to be. However, traditionally just know that it's the horizontal, then the vertical point. Alright, next slide. Alright, now we're going to be analyzing graphs. What does that mean? Well, the graph at the right represents the speed of a school bus traveling along its morning route. Describe what's happening on the graph. Well, first of all, you need to be, as an intelligent reader, look at your label. What's going on with your label? Your x-axis is time. So here is the start, 0 time. Here is the end of time. Speed, that's your y-axis. All right, so there's 0 miles per hour, and here is a lot, or going fast. Okay, so as we get going, we start at 0 time, 0 miles per hour. The bus speeds up, time moves on. So the bus is accelerating. All right, so now, maintaining speed. Time is moving, but the speed is staying the same. The bus is slowing down. So the speed is slowing down, but time is still moving, so we have to go to the right. The bus is stopped. Time is still passing, but there's 0 miles per hour. All of a sudden, notice we're doing the same pattern. We're speeding up, maintaining speed, slowing down, stopped, speeding up, maintaining speed. Okay, very good. Moving on. Now we need to identify the graph that represents the altitude. Okay, so first of all, there's a vocab word. What does it mean to be the altitude? Well, you should know that altitude means the height. So, the height of the space shuttle above the Earth, from the moment it is launched until it lands. So that's important to understand what is the definition of what you're looking for. All right, the answer is A. From the time it's launched, the space shuttle increases in altitude, orbits the Earth, and then lands. Very good. So here's the answer right here. Now, the reason it's not B is from the time it launches, it goes up, it orbits, and then it never lands. The arrow means it just stays in outer space. So this is no. Graph C, altitude. Well, that means the space shuttle is already in outer space, and then it lands. So there's no launch. That's why it's no. All right, so there's that part. On the last page, we're looking for how to draw graphs. So basically, the first thing is make a table showing the cost of buying 1 to 5 CDs. Now there's a special here. For every 2 DVDs you buy, you get the third one free. So you buy 1, it's $29. You buy 2, it's $58. You don't have to buy the third because it's free. So that's why it's $58. But then you buy the fourth, so it goes up another $58. Buy the fifth, it's $116. Now this pattern continues. First thing you need to remember, this is your independent variable. This is your dependent variable. The cost depends on how many you buy. Okay. Now, when we want to graph it, the domain and the range. The domain is down here. So we're looking for which one is the domain. That is the independent. So here's your domain. Here is your range. Domain is always your x variable. Range is always your y variable. So if you had to graph them in a table, you would have x and y. And you could use it from this table here and just place it down. Or you could use the ordered pairs that they've listed out here. That when x was 1, y was 29. When x was 2, y was 58. X was 3, it's 58. 4 is 87. And 5 was 116. So here's your domain. Here's your range. Again, usually it always reverts back to alphabetical. D comes before R, X comes before Y. All right. So that was chapter 1-8, just making sure that you can actually be able to read and interpret graphs. If you have any questions, please make sure you can see Mr. Jameson.